Today we are going to be discussing the difference between two solubility classes. The first one is hydrophobic compounds. Hydrophobic compounds don't dissolve in water. You can think of these compounds as having a fear of water. A few examples of hydrophobic compounds are cholesterol, triglycerides, and fatty acids. A good thing to remember about hydrophobic compounds is that molecules with less than one polar functional group for every 5 carbon atoms are water insoluble. Two examples of functional groups are carboxyl and carboxylate. This is what a carboxyl group looks like. And this is what a carboxylate group looks like. There may be a polar functional group in the biological compound. However, if the nonpolar group is much larger than the polar group, then it will not dissolve in water.
The second solubility class that we will be discussing is hydrophilic compounds. Hydrophilic compounds are soluble in water. You can think of them as being water-loving. Hydrophilic compounds are water-soluble because they have polar groups and/or can form hydrogen bonds. Hydrophilic compounds are like water. Some examples of hydrophilic compounds are carbohydrates and amino acids. Some more specific examples of carbohydrates are starch, ATP, RNA, and corn syrup. A good thing to remember about hydrophilic compounds is that molecules with at least one or more polar functional groups for every 5 carbon atoms are water-soluble. Two examples of polar functional groups are carbonyl and hydroxyl. This is what a carbonyl group looks like. This is what a hydroxyl group looks like. Formal charges also increase the chance of a biological compound's ability to be soluble in water.
We're going to demonstrate what would happen when a hydrophobic compound, such as vegetable oil, is placed into a polar solvent such as water. First, I'll pour water into the empty glass. Now I'm going to pour in the vegetable oil, which is the hydrophobic compound. To further prove that the vegetable oil is hydrophobic, I'll mix the water and vegetable oil together. As you can see, they stay separate. Nonpolar solutes only dissolve in nonpolar solvent. This is a real-life example of what would happen when you put a polar solvent such as water into a hydrophilic compound such as salt. As you can see that after a minute of mixing it, all the salt particles dissolved in water. We thought it would be fun to test your knowledge on what you've learned so far based on our explanations through the videos and our real-life examples on hydrophobic and hydrophilic compounds. So we have 2 questions for you guys today. So our first question for you is, what is one example of a hydrophilic compound? Pause the video to answer your question. Your answer could have been one type of carbohydrate, such as starch, ATP, RNA, or corn syrup, or an amino acid. Our second question for you guys is, what is one example of a hydrophobic compound? Pause the video to write down your answer. One of the answers to the question that I just asked you could be fatty acids, cholesterol, or triglycerides. I hope that our real-life examples and our explanation in the videos of the difference between hydrophobic and hydrophilic compounds can help you understand the difference between the two.